Hi everyone. Today we will try to understand what is continuous bag of words CBoW, which is a neural network methodology that is followed to generate numerical representation out of text data. So as we know that text data can't be fed in directly into any machine learning model or neural network. So it is a method by which we are able to convert a text into its numerical representation. So let's get started. So before we move ahead, we must understand the concept of n neighbors. So n neighbors, when we would be using in this video, we mean that n neighbors of a word on both the side of the word. So for example, if you see in the sentence, a quick brown fox jumps over the lazy dog, the first sentence, and if I pick up the word jumps, then if the n neighbors equals to two neighbors that we wish to know. So two neighbors from both the side, that is brown fox and over the. These will form the n neighbors for jumps. So let's get started. So in case of continuous bag of words, what we're trying to achieve is we take up n neighbors of a given word as an input and try to predict that particular word as an output. So first of all, we will be preparing our training data set. So how the training data set is prepared. So if you look at the source text, the quick brown fox jumps over the lazy dog. So here we will start from the very first token, that is word, that is the, and we will look out for its n neighbors from both the side, as it really doesn't have any word on the left hand side. So we will be considering its n neighbors on right hand side only. So if n equals to 2, then we will considering starting two words, and you can see our feature set becomes quick brown and the target becomes the. Similarly, once we take a step ahead, we will slide over this window and we move on to the word quick. Now, in case of quick, as you can see, we have just one neighbor on the left hand side and two neighbors on the right hand side. So, until and unless whatever we are getting, we will take it from the left hand side if it is not equals to 2. So, we'll take one neighbor from left hand side and two neighbors on right hand side. The brown fox and our target variable becomes quick. Similarly, we'll move ahead towards brown, and again we'll pick up two neighbors from left hand side, two neighbors from right hand side. And when we come on to fox, so you can see that we have picked up two neighbors from left hand side, two neighbors from right hand side, and we have skipped the words the and the lazy dog. Now, as you can see, our training data set is prepared where the neighboring words are forming the feature set, and the word that we wish to predict becomes our target variable. Now, what next we are trying to do is feed all these words together into a neural network, and eventually we are trying to predict the word that the of which these words are neighbor, that is fine. So in case of an example, I am selling these fine leather jackets, uh, and if n equals to 2, and we are trying to forecast for fine. So selling these and leather jackets becomes our input. Eventually they get merged up together in a single layer here, and eventually they are trying to predict the word fine. Now how but this is all great, but where are we getting our embeddings? So the embeddings are present in this particular layer. So the weights of this layer just before the final prediction will be taken up, and this will form our text embedding for the entire data set. As this is just an example, we will be training like this for all the samples that will generate from our text data set. Now moving on to Skipgram. Skipgram is exact opposite of CBoW. So in case of Skipgram, what we're trying to achieve is that given one neighboring word, we are trying to predict the target word. So the concept of n neighbors remains the same, but what we're trying to do is we will take up all the neighbors one at a time in the training set. So for example, the quick brown, if n equals to 2, so we'll be picking up quick and brown in the feature set, and the as a final target to be predicted, but one at a time. So quick becomes our input and the becomes our output. Brown becomes our input and the becomes our output. So in case of SIBA, what we were doing is that we were taking all these neighbors together, but here we will be taking them one by one. Similarly, looking at the third example, the quick brown fox jumps, where brown is a target variable. So we have picked up two neighbors from left hand side and two neighbors from right hand side, and eventually each of this word becomes an input, and the target becomes our center word, that is brown, the brown, quick brown, fox brown, and jumps brown. Now, as you can see in the diagram, we are feeding all these words. In case of I am selling this fine leather jackets, again assume that we are trying to forecast fine and n equals to 2. So in case of skip grams, what we are doing is we are eventually feeding each word separately. As here we were feeding them into a single layer. Here what we're trying to do is we are feeding this network separately and trying to fine tune and trying to predict our final find. Now